Greetings everyone. You are welcome to this video tutorial. In this video tutorial, we will talk about queues in C++ and especially circular queue as an array. Now let us first discuss the disadvantage of normal queue, why there is a need to introduce circular queue. So the normal queue suffers from one major drawback. As arrays are fixed in size, elements cannot be inserted beyond the maximum size of the array, even though in reality there might be empty slots in the beginning of the queue. So we take this scenario. There are six. This is a queue in which you can insert 6 elements from 0 till 5. You can see here the front is 2 and rear is 5. And if we consider this queue will be treated as full because rear has reached max minus 1. The maximum element size has been reached. Although there are few empty slots, 2 empty slots in the beginning of the queue. But this queue is considered as full. So this is one of the major drawback of normal queue. Although when there are empty slots in the beginning, queue is considered full when rear reaches max minus 1. So this is the disadvantage which will be recovered in the with the help of circular queue. Now let us understand what is a circular queue. Array implementation of circular queue uses an array to store data and an integer type variable usually called the front, which points to the beginning of the filled array, and an integer type variable rear, which points to the end of the filled array. So you can see here, this is an example of a circular queue. This is nothing but an array, and in this case you can store 5 elements from 0 to 4, and then there is an integer type variable front which contains the index number of the very first element of the queue, and rear contains the index number of the last filled element of the queue. The very thing which is special about circular queue is when the number of additions makes rear equal to size minus 1 of the array, the next element is inserted in the first slot provided it is free. So you can see here in the beginning there were 2 elements at 0 and 1 position also which were deleted, and now my front is at index number 2 which contains values 30, and after insertion of 50 my rear reaches 4, which is the maximum size of the array. But since there are empty spaces, empty slots in the beginning of the queue, that is why if I want to insert more element, I can insert it at the index number 0 or at the index number 1 also. So even if the rear reaches max minus 1 and there are empty slots in the beginning of the queue, we can make rear equal to 0 or and further to insert more elements in the queue. Now let us understand the operations on circular queue. A circular queue is a linear data structure like normal queue. It is controlled by 2 operations, insertion and deletion. Insertion operation takes place from the rear end of the queue and deletion operation takes place from the front end of the queue. So whenever a new element is inserted, it is inserted at the rear end, and whenever an element is deleted, it is deleted from the front end. Now there are 2 variables, front and rear. Front points to the beginning of the queue and takes care of deletion operation, and rear points to the end of the queue and it takes care of insertion operation. If rear reaches the end of the queue, then the next insertion operation makes rear equal to 0 provided front is not 0. So in this case you can see my front is 2. So after inserting 50, when the rear reaches the maximum element which can be inserted in the queue, if my next 2 elements in the beginning of the queue were empty, so I could insert 60 also at the position 0. So after reaching here, I can make my rear equal to 0 to make the next insertion possible. If the front reaches the end of the queue, then the next deletion operation makes front equal to 0, provided there are more elements in the queue. So if I keep on deleting elements from here, my front will come here, then my front will come here if I delete 40 also, and if I delete 50, my front will come here. Circular queue insertion operation. Now initially when the queue is empty, front and rear can have any integer value other than any valid index number of the array. So we can initialize front and rear by -1. It should not be any valid index number, and valid index numbers of an array start from 0. The first element in the empty queue goes to the 0th position of the array, and both front and rear are initialized to value 0. So when the very first element is added to the queue, it goes to the 0th position, and in this case both front and rear, they become 0. After this, every insertion operation increases the rear by 1 and inserts new data at that particular position. So whenever insertion takes place, front is not changed and only rear is incremented by 1. And if rear reaches the end of the queue, then the next insertion operation makes rear equal to 0, provided front is not 0. So if we keep on inserting data and if my rear reaches the end of the queue, then the next insertion operation makes rear equal to 0, provided my slots are empty here and my front is not 0. Now the queue is full when rear is equal to front plus 1, or front is equal to 0 and rear equal to max minus 1. This is the original condition of the normal queue also. When the front is 0 and rear is max minus 1, the queue is full. But in this case, one more condition is there. If rear is equal to front plus 1, then also the queue is full. An insertion at this point will result in data overflow. Now let us understand it with the help of a diagram. Now suppose this is a queue in which of size 4 and in which already the 3 elements are inserted. So my front is 0, as you can see here, 10, 20 and 30 are inserted. My front is at 0 and rear is at 2. Now if I want to insert one more element, this is insertion, deletion. If I delete an element from the queue, then deletion will take place from the front end. So the element is deleted, this element will be deleted and my front will become 1. You can see here front is pointing to 1 now and rear is 2. Rear remains unchanged and rear will point to 2 only. Now if I insert one more element to the queue, so if I am inserting 40, so my front will remain 1. I will simply increment rear. Rear was 2 initially, earlier. So I will increment it by 1 and my rear will become 3 and my element is inserted like this at the index number 3. So rear is 3 and front is 1. So if this is the case of normal queue, my queue will be treated as full, because in the normal queue, when rear reaches the end of the queue becomes full. But now we are talking about circular queue. So there is an empty slot in the queue. So this queue will not be treated as full. Let us see how. Now we are further performing one more delete operation. So if we delete an element, the element which is at the beginning of the queue, that is 20 here in this case, will be deleted. So my front will be incremented by 1 and front will become 2. Rear will remain 3 and front will become 2. Now suppose I want to insert one more element. So you can see here rear is at 3, which is the end of the queue. Now insertion of one more element will make rear equal to 0. So my new element will be inserted here. One more element, you can see here when new element makes rear equal to 0. So when my rear reaches the end of the queue, insertion of one more element makes rear equal to 0 and my front will remain the same. If I want to insert one more element, suppose I want to insert 60. So again rear is incremented by 1. So earlier rear was 0. So it will become 1 and 60 will be inserted here. You can see here. So after the insertion of 60, you can see the queue is full because my front is equal to rear plus 1. You can see here front is 2 and rear is 1. Front is equal to rear plus 1. In this, the condition is true. So my queue is full. And if I want to insert one more element, this will result in data overflow. Now let us understand the delete operation. The delete operation deletes the very first element from the queue, and any attempt to delete an element from the empty queue, that is when front and rear are -1, results in data underflow condition. So when the queue is empty and if we try to delete an element, it will result in data underflow. Now each time the deletion operation is performed, the front variable is incremented by 1. We simply increment by 1 to delete the first element of the queue. When there is only one element in the queue, deletion operation of that element makes the queue empty. And both front and rear, they will be assigned the value -1. Now when front reaches the end of the queue, suppose I keep on inserting, keep on deleting data from this queue, and when front reaches, after deleting 30 and 40, if I reach here and if I delete this element also, my front will become 0. So when front reaches the end of the queue, then the next deletion operation makes front equal to 0. Now let us understand it again using this memory diagram. Now suppose this is the structure of my queue in which there are 4 elements and my front is at 2, you can see here, and rear is at 1. Front is equal to rear plus 1, so my queue is full in this case. Now suppose when I delete an element from the queue, then the element which is present at the beginning of the queue, in this case the beginning is 30 because it is being pointed to by front, so this will be deleted. Automatically the element which is being pointed to by front is deleted. So this element is deleted and front is incremented by 1. So my front will become 3. Earlier my front was 2. So it will become 3 and rear will remain unchanged. Now if I make one more deletion operation, so the front which is pointing to element present at index number 3, that is 40, will be deleted and my front will become 0 now. That is, when front reaches the end of the queue, the deletion of this element will make front equal to 0, provided there are more elements in the queue. So my front is now 0 and you can see rear remains unchanged and it is 1. If I perform one more deletion operation, then deletion operation will make, again it will delete the element which is pointed to by front, that is element which is present here, that is 50, and both my front and rear, they become 1. Front is simply incremented by 1 and both front and rear, they will point to element which is present at index number 1. Now if I perform one more deletion operation, then in that case this element is deleted and my queue becomes empty. So both front and rear will become -1. And if I try to perform one more deletion operation, this will result in data underflow, because this is underflow, this is not overflow, this is the underflow because my queue becomes empty. Now display operation. Display operation of circular queue is somewhat different from normal queue. Now let us understand how to perform display operation in the case of circular queue. The display operation displays all the elements of the circular queue from front till rear. We always display elements beginning from front and go till rear. Now it will check whether front is less than rear or front is greater than rear. In normal queue, front is always less than rear, but in the case of circular queue, we can also have front greater than rear. So we'll check. Now if front is less than rear, it will simply display all the elements from front till rear. So there will be no discrepancy. Simply, if suppose my rear is here, so it will display elements from front till rear like the normal queue. But if front is greater than rear, then in this case, as you can see the case here, here the front is 2 and rear is 0. My front is greater than rear. So in this case, first it will display all the elements from front till the size of the queue, that is size -1 in this case, which is 4. And then it will display all the elements from 0 till rear. So in this case, the rear is at 0. So first it will display 30, 40, 50 and then it will display 60. Like this it will happen. Let us understand it more closely. So let us look at both the cases. Now in the first case, you can see my front is 0. This is my front and this is my rear. Rear is 2. So if this is the case, we simply apply a for loop and we will initialize the control variable I of the for loop by front and we will go till rear and increment I by 1. Simply display like this. 11 is displayed first, then 12 and then 13. But if this is my queue, we can see in this case front is 2 and rear is 1. So front is greater than rear. So in this case we will use 2 loops. First it will display elements 13 and 14, element number 2 and element number 3, index number 2 and index number 3, and then it will start from 0 and go till rear. So it will display element number 0 and index number 0 and index number 1. So we will be requiring 2 loops, one from front till max -1 and the other from 0 till rear. Now let us see the program to illustrate operations in circular queue. We will first include 2 header files and this is the for size of the queue. Now this is the class circular queue which I am declaring, and in this I am declaring integer type array of this size and I'm declaring two variables, integer type, front and rear. Now in the public section, there is a constructor where front and rear, they are initialized by values -1. And then we have three functions: insert, remove and display. Now the insert function, we are passing the value which is to be inserted. So we first check if there is a space in the queue or not. So if rear equal to size -1 and front is 0, or front equal to rear +1, in both the cases, in either of these cases, my queue is full. So I will display the circular queue full and I will return. Otherwise, if my queue is not full, I will check if rear is -1, it means my queue is empty, and adding an element to an empty queue increases both front and rear by 1. So both of them will become 0. If my queue is not empty, I will check if rear equal to size -1. It means if rear has reached the end of the queue, in that case, I will make rear equal to 0. Otherwise, I will simply increment rear by 1. After setting all this, I will simply input the data, and the data I have already have, sorry. So I will simply assign this data to the required position. Data rear equal to none. Now to remove or delete an element, I will first check if front is -1, it indicates that my queue is empty. So I will simply return, it will result in queue underflow. And otherwise, I will display the data which I am going to delete. This is not a mandatory step. We can skip this step also. This will display the data which is present at the beginning of the queue. Now I will check if front is rear. It means there is only one element in the queue. Then deletion of this element will make both front equal to -1 and rear equal to -1. Otherwise, if there is one element is not there, there are more than one element, then in that case, I will check if front equal to size -1. That is, if my front reaches the end of the queue, then I will make front equal to 0. And otherwise, I will simply increment front by 1. Now let us come to the display operation. In the display operation, as we have already discussed, I will first check whether front is less than rear or not. If front is less than rear, I will simply use a loop. I will initialize the control variable I by front. I will go till I is less than equal to rear and I plus plus, and I will simply display the data which is present at the index number I. Otherwise, if my front is greater than rear, I will use two loops. You can see here. I will first run the loop from front till size -1 and display the data from front till size -1, and then I will run another loop from 0 till rear and display the data which is present at these index numbers. Now after defining the class, I will define main, in which I will create an object of circular queue class, and this is a temporary variable. Then I will run a do while loop, and 1 is for insert, and 2 is for remove, 3 for display, and 4 is for exit. I will simply input the choice and I will check if it is 1, I will call the function insert, set 2, then I will call remove, and 3 for display. And if I enter 4, then I will exit. Now let us see the sample run of this program. Now when I run this program, this menu will be displayed. In the beginning, you can see my queue is empty and front is -1 and rear is also -1. So in the beginning, I will first insert an element in the queue. I will choose the choice 1 and I will input the item number. I will input value 11 into it. So when I input 11, this is the only element in the queue. So both front and rear, they will be incremented by 1 and they become 0. Now the menu will again be displayed. I will insert one more element, 12 here. You can see when I insert an element, rear gets incremented and front remains 0. Now again the menu will be displayed and I enter the choice 1. Now this time I am entering data 13. So if I enter data 13, so in this case again rear is incremented by 1 and rear becomes 2. Now again the menu will be displayed, and now I am deleting an element from the queue. So if I delete an element, I will choose the choice 2. So the element which is deleted will be 11. As you can see in this case, 11 is the first element which was inserted in the queue. So this will be deleted first. So this is my front becomes 1. Front was earlier 0. You can see here. Now my front will become 1 and rear remains at 2. Now again after deleting 11, the menu will be displayed again. And suppose I choose the choice 2 again. So in this case, as front is pointing to this element, 12 will be displayed and my front becomes 2 and rear remains at 2. So you can see there's only one element in the queue, so both front and rear are same. Now again the choice is displayed, and this time I will insert an element, and I input 14. So you can see here rear is incremented by 1 and rear becomes 3 and 14 is inserted at the index number 3. Now again the menu will be displayed, and I am inserting an element into it, suppose 15. So you can see here rear has reached the end of the queue. So the next insertion of next element will make rear equal to 0 because there are empty slots in the beginning of the queue. So you can see here rear has reached 0, rear has become 0 and front is still 2. Now again, if I menu is displayed and if I again choose choice 1, I'm entering data 16 here. So if I enter 16, you can see rear is again incremented by 1. So rear becomes 1 and 16 is inserted at this position. So you can see here my queue is full and all the elements are inserted in the queue. So this is all for this session, and I hope you like this video, and if you like it, please give thumbs up, and you can also subscribe to my YouTube channel. Thank you.